Welcome to the mysterious and fantastic world of pipes, pressure, joint restraint, and bulldozers.
Bulldozers? What do bulldozers have to do with pipes, pressure, and joint restraint?
Be patient, my questioning one. Join me for a few minutes, and we'll explore each of these matters in turn. First, let's consider pipes. Pipes hold water, and the water is under pressure. Therefore, the pipe not only has to contain the water, but also has to be strong enough to withstand the forces generated by the pressure.
But what about the bulldozer?
Just sit back and relax. We'll get to the dozer shortly. Looking at the water pipeline, we can see that in the case of a long and straight line, the force of the pressure is balanced and all is well. But when the pipeline needs to make a change of direction or a change of diameter, we encounter an unbalanced force at the fitting, and all is not well.
Well, I don't understand the problem. Is this where the dozer comes in?
My, you are an inquisitive one. Just let me explain. Back in the Dark Ages, people relied on concrete thrust blocks to transfer this unbalanced force to the surrounding soil. The modern man walks upright, has opposing thumbs, and uses joint restraint to resist the unbalanced force at a fitting.
Well, just how much force are we talking about?
Well, when pressure acts on an area, a force is generated. For example, a 12-inch water main has a cross-sectional area of about 137 square inches. Let's say that this line is operating at a pressure of 75 pounds per square inch, and that we come to a dead end in the line where the modern man, you know, the thumb and all, has installed a restrained mechanical joint end cap.
Why would he do that?
Oh, who knows? Maybe future man is going to build a new subdivision or a shopping mall. The reason is not important. Let's just say that he did. Well, as you can see from our example, that generates 10,250 pounds of force.
Wow! Over 10,000 pounds of force from only 75 psi? No, wait a minute. 75 psi, that's not a lot. What if the pressure was even more?
I'm glad you asked. In these areas, the wise and modern man uses really good joint restraint, such as the MEGALUG by EBAA Iron.
MEGALUG? EBAA?
Yes, the MEGALUG. This ingenious restraint device can restrain the end cap in our example up to 350 pounds per square inch continuous working pressure.
350 psi? How much force does that generate?
47,900 pounds.
No way. That's as much as 500 rocks, or 10 pickup trucks, or even...
Yes, even a large bulldozer.
Yeah, a large bulldozer.
And just to prove it, the engineers at EBAA used two 12-inch megalugs, a piece of ductile iron pipe, and an 80-ton motor crane to lift a D7 Caterpillar. See for yourself.
That's incredible! You mean to tell me that the entire weight of the dozer is being supported by the MEGALUG's grip on the pipe? What kind of force does that generate?
The D7 weighed 50,350 pounds. That's the equivalent force of 368 pounds per square inch.
This is very impressive. They must have a lot of confidence in their product.
That's not all. Since a D7 is really not difficult for the MEGALUG and ductile iron pipe, they went on to lift the same dozer with their Series 2000 PV for use on PVC pipe.
Now, wait a minute. Isn't PVC pipe made of plastic?
Precisely.
Wow. Now, hang on. Iron pipe is one thing, but this is plastic. Are you sure there's not a cable or a bar running through that pipe?
No cable, no bar. No smoke, no mirrors. All of the weight of that dozer is being held by the 2000's grip on the DR18 PVC pipe, just like the MEGALUG on the ductile iron pipe.
Is this the type of thing that EBAA engineers typically do for fun?
Well, yes, sometimes.
Now, these MEGALUGs sound pretty good. Hey, where can I get some?
Well, what on earth for?
I don't know. Maybe I want to build a subdivision.
Well then, I suggest you call EBAA Iron at 1-800-433-1716.